Good morning, my YouTube viewers. It is Crystal here, and I wanted to do another code review for you. This is Kaggle's Playground Series, Season 3, Episode 5, and it's about wine quality. So basically what they did was they took the wine quality data set and they did some more work to it, and that's what we're going to be making predictions on. So I did the code and I submitted the code to Kaggle and I got 52% accuracy, which isn't great, but the highest accuracy was I think like 57%. So I only scored like 5 points less than the highest person scored, but you know, that's not a great level of accuracy. So what I did was I created the program on Kaggle's free online Jupyter notebook that is stored in the directory of the Playground series. And this is the problem statement. So the data set for this competition, both train and test, was generated from a deep learning model trained on the wine quality data set. Feature distributions are close to, but not exactly the same as the original. Feel free to use the original data set as part of this competition, both to explore differences as well as to see whether incorporating the original and training improves model performance. Well, I didn't do that. The way you'd have to do that is you'd have to import the original data set, which I didn't do. I have imported data sets on occasion for some problems, but I didn't do it on this particular problem. So after we created the notebook, the first thing that we need to do is we need to import libraries. So libraries are just units that have functions in them that make it easier to work, so the coder doesn't have to make all of these functions from scratch. So the first thing we do is we import NumPy as NP, which is a numerical computing library. We import Pandas as PD, which is a data processing library that also creates data frames and series. We import OS, which goes into the operating system. We're going to import sklearn, which is a machine learning library. We import matplotlib plot as PLT, which is a graphics library. And we're going to import Seaborn as SNS, which is also a graphics library that has statistical functions in it. So after we have imported our libraries, what we want to do is we want to use OS to load the files, and we put OS in a for loop to retrieve the files, and the 3 files that we retrieved were train, test, and sample submission. After we have retrieved the files, what we want to do is we want to read the files, and we use Pandas to read the files and convert them to data frames. So we convert them to train, test, and submission. So here is your train file. It's 2056 rows by 13 columns, and you can see the quality is the last column, and the quality is a multi-class target. We check the test. The test is the same format as the train, except for the fact that it doesn't have a quality. And what we're going to do is we're going to make predictions on what we think the quality will be. And then we check submissions. This is the format that Kaggle wants to see when we submit our work. So the next thing we're going to do is we're going to analyze train. So we check train info, and we see all of the columns are numeric, so that's good. So there's nothing to encode. We check for any null characters. We don't have any null values, so that's good, so we don't have to deal with null values. We check value counts to see if there are any qualities that appear only once. And note, there's no qualities that appear only once, so we don't have to deal with that. And then we analyze the target, which is the quality column. And so you can see this is the target here. And you can also see that there is a class imbalance, that most of the quality is between 5 and 6, and then the lowest quality is 3, and then 4, and then an 8. So you can see that there's a class imbalance here that needs to be dealt with. I did a little scatter plot, so you can see a scatter plot. I wanted to do a box plot, but there were too many unique variables in all of the columns to be able to do a box plot. But here's your scatter plot. We check the number of unique values in each column. So if you look at the number of unique values in each column, you can see that there's too many unique values for me to do a decent looking box plot, so I didn't do it. Well, I did do it, but it didn't look decent, so I deleted it. Now we're going to combine the train and the test set. So we define the target as being train quality, and then combi equals train dot quality, axis equals 1 dot append test. And then so what we have done is we have appended the test to the train. Now we're going to drop the ID, and you don't need the ID because every row is indexed. We check for null values again. There's not any null values, so that's good. So we don't have anything we have to impute or deal with. Created a heat map to see which columns correlated to each other. So core equals combi.core, and then sns.heatmap core. So you can see that none of the columns have a really high correlation to each other. So I did not insert any code to remove columns. The reason why is because we didn't have that many columns to start with, and if I had inserted the code, it wouldn't remove the columns, because you can see from the heat map that the columns don't have a really high correlation. So the citric acid, let's see what we've got here. It says the citric acid is a little bit of a high correlation, and but no, so I didn't do that. I didn't insert any code to remove columns because there weren't that many columns anyway. And what I did was I normalized combi. What happens when you normalize combi is you convert all of the cell values to a value between 0 and 1. And the reason why that is because the model is able to make better predictions, is able to train the data and fit the data better if all of the data is really close together. So that's why I normalized it. So now what we're going to do is we're going to define our x and our y variables. Y variable is your dependent variable, and it's your target, being the quality of the wine. X is the combi up to the length of train, and x test is combi from the length of train to the end. And so now what we do is we split our training set into training and validation sets. So x target equals target, and then train equals x dot sample, frac equals 0.9, random state equals 42, val equals x drop, train dot index. So basically it drops all of the rows that were in train. And then x train equals train dot iclock, colon, comma, colon, -1, which means it's accepting all of the columns except for the last one. y train equals train.ilog colon common -1, which means it's accepting the last column. And then x val, y val are done in exactly the same way. And then we check the shape as well. So the shape is, you can see you've got 12 columns for the train in the test set and 1 column for the train in the test set. The x-axis, and we've got 1 column for the y-axis. Now what we do is we select our model, and in this instance I selected the extra trees classifier. So model equals extra trees classifier, class weight equals balanced, random state equals 42. And then we fit the model and we look at the score, and the score is 100% when we train and fit the training data. So now we predict on the validation set, and when we predict on the validation set, we only have close to 60% accuracy. So that indicates that it was a little bit overfitted, because if you've got a high accuracy on the training and fitting, but not so high accuracy on the prediction, that means that it's a little bit overfitted, but there's not a lot I can do about that. Checked our confusion matrix. You can see we've got a confusion matrix for all of the 6 qualities, and as you can see here, there's nothing for 3 and 4 and nothing for 8. So what that indicates is the class imbalance was not addressed, even though I put it up for class weight equals balanced. Now, one thing that you could do if you wanted to is you could use a smoke. A smoke is one way to deal with a class imbalance, and that is oversampling, and then the target. And another way that you can deal with the class imbalance is undersampling of the independent variables. So there are several ways that you can deal with oversampling, and what I decided to do was I just decided to use the model, and extra trees model is supposed to be a good model that deals with the class imbalance, but it didn't really deal with the class imbalance on this occasion. So we compare the actual values to the predicted values, so you can see the comparison, and then we predict on the test set, and then we set our test set up to be submitted to Kaggle, and so we submitted it to Kaggle, and as you can see, it really only had 5, 6, and 7. It didn't have 3, 4s, and 8s. So this isn't a fantastic model. What I would need to do is I would need to experiment with some different models to see if I could improve my score. But as I've said, the highest score was 57%, I believe. So this is a hard data set to work on, which is why Kaggle gave us this data set, because they intentionally gave a data set that has a lot of problems that would give us something to work on. And in order to deal with these class imbalance, you can do it oversampling, or you can do it undersampling, or you can select the model, or you can get more data. So I could have oversampled, undersampled, or selected the model. So in this instance, I selected the model. But let's go ahead, now that we've done this code review, and then we checked it on decision trees, extra trees. Now that we've checked it on extra trees, let's come over here. So we did logistic regression. I think this was the logistic regression one. So This is our confusion matrix for the logistic regression, and you can see for the confusion matrix for the logistic regression we had representation and all 6 of the quality classifications, and since we had representation in all 6 of the classes, that indicates that logistic regression is actually a better model to use. And what I use with logistic regression, I use the class weight was balanced, multi-class equals multinomial, C equals 100, max IDER equals 5,000, random state equals 42. So even though I didn't score as highly on logistic regression as I did extra trees, logistic regression was actually a better model because it gave you representation for all 6 of the classes, whereas extra trees didn't. So that's just something to think about. And then if you go into the leaderboard, so here I am on the leaderboard, way down here. Okay. And another thing that you can do is you can check the code, and you can look at the code of other people and see what their answer was. So you see right here, you've got this LGBM multiclass, and they got 56%. So what they did was they used light GBM, which isn't an sklearn estimator. So those are some things that you can do to improve your skills. So there we go. There you have it. So even though extra trees scored more highly than logistic regression, it appears that logistic regression was actually a better model because it gave you representation for all 6 classes, whereas extra trees didn't. So that's just something to think about. So I'm going to go ahead and conclude this code review because I've covered everything that I wanted to cover. And I look forward to communicating with you in the next code review. I would like to thank all of my subscribers for supporting my channel. If you like my video, please like, subscribe, and share. And thank you again for watching my video.